Next question we will try to answer is what are the relative amounts of phases present? So we were discussing about the phase diagrams. So here we are going to discuss about what are the relative amounts of phases present for a particular uh, constitution point. Yes. Okay, so let me draw the phase diagram. Okay, so we are taking the copper nickel alloy is also here, that is copper and nickel here. So for a given constitution point, let us take A. So we know that what is the composition of the alloy at A, and also what are the phases present. But so really for particular case, this A here, you have here alpha phase, here liquid, liquid plus alpha. For particular that point A, you have only the alpha phase present. So 100% is alpha, okay, 100%. But if you take a point here, let it be B. So you know that at point B you have liquid and alpha phase. But what is the percentage of liquid and what is the percentage of alpha phase? Right. So to find that, okay, so let this be just drawing it. Let here the composition here is let it be 30% nickel. Okay. So again for this we will draw a diagram. So let this be um, 10% nickel and this be let it be 50% nickel. Okay, so I am just assuming that. So uh, so we will first draw to find the relative amounts uh, of these phases present. Uh, First, what will I do? I will draw a timeline. Draw a timeline here. Okay, then uh, I will make use of the lever rule. Okay, what is the lever rule? Here you can see that. So this is the lever. So I place a lever at this point P. At this point P. So let these points be A and C. Okay. So fraction of alpha percent can be found out from this. Okay. So fraction of alpha can be found out uh, from the percentage of this length and fraction. So this is F alpha and the fraction of this can be found out from this length. Okay, so that means F alpha is equal to BC by AC and F of liquid is equal to AB by AC. So this is the formula for finding fraction of alpha and fraction of beta. So you will just take the opposite side. Okay, so this rule is based upon the mass balance rule, which we are not going to derive. But this is how you find the relative amounts of phases present. So F alpha, so for this particular example, let us find it. So F alpha here will be equal to this C point, that is 50% nickel. So 50 minus 30 divided by 50 minus 10. So this is equal to 20 by 40. So this is 50% of alpha. Okay. And for liquid, so we will take the AB. Okay, so this is AB. This AB, you can write it as 30 minus, so it is 30 minus 10 divided by 50 minus 10, that is 20 divided by 40, that is 50 percentage liquid. So these are all equal percentage. You can use the same rule, for example, maybe here also, right? So, so maybe for example, for this particular point C, okay. So for this particular point C, so here also I will draw a line here, okay. So the fraction here represents the fraction of alpha, and fraction here will represent the fraction of liquid. Okay, these are the two fractions that is present. So based upon these lengths, um, so let us call it Q. So let us do it PQR. Okay, based upon this, you can find the fraction of liquid and alpha.